Hello friends, welcome to the world of geometry. Yes, now we are starting with geometry module videos. Okay, the very first topic will be all about lines, angles and triangles, and triangles is going to be the most important foundation pillar of the entire geometry. If you're good with triangle, most of the things are sorted, line of thought is clear. Second is polygons and quadrilaterals. All right. Third is circles. Yes. Fourth one is 3D and geometry. All right. Sorry, 3D mensuration. That is volumes and surface areas. Okay. So let's get started with the very first topic, lines, angles, and triangles. After this video, you will be empowered with all the knowledge about triangles. Yes. So you will be ready to face the further geometry part. Okay. All right. Let's see. Okay. You know, skills required for other fields in maths. Geometry requires one extra skill. What is that one extra skill, friends? Tell me. Come on. One special, unique skill exclusively for geometry. Yes, visualization. What does that mean essentially? This means the skill to see not just what is told, but what all is there in that figure. Can you see everything? Whatever is not written. That is the main skill called as visualization. All right. You'll understand this even better once you start solving the questions. Cool. Let's go ahead. Lines, angles, and triangles. Okay. All right. So let's first see all the basics, the vocabulary, the main keywords with the help of which we will build up the entire ecosystem of geometry. Okay, let's see, friends. First three words, line, ray, and segment. Come on. Yes. So line is nothing but it extends infinitely on both sides. If you cut it at one end, if you stop it at one end and it extends infinitely on the other side, then we call it as a ray. Yeah, and if you cut it the other end also, so you will see that something called as a segment which is fixed at on both the ends, fixed on both the ends, right? You can exactly measure. If it is fixed on both the ends means you can exactly measure this length, right? Out of all these three, segment is the one whose length you can easily measure. So you should be very clear between these three words. Okay. All right. Let's go ahead. Collinear points and concurrent lines. Now, whenever I take any 2 points, friends, we can always join them by one straight line. Yeah. So 2 points by default will always lie on the same straight line. Okay. So in the third point, if I take a third point, if that point lies outside that line, then we call it as non-collinear. And if the third point happens to lie on the same straight line, then we say that these points are collinear. That is why the definition goes like this. Three or more points lying on the same line, they are called as collinear points. Okay. All right. Now concurrent lines. You know, friends, with respect to two lines in a plane, there are two choices. Either they won't intersect, so they'll be parallel, or they will intersect, right? So if they intersect, they will intersect at one point only. So if you happen to see that the third line also passes to the same point, then we say that these three lines are concurrent, isn't it? That is why the definition goes like this. Three or more lines passing to the same point. Just see this. Okay. These are concurrent lines and that point is called as point of concurrence. All right. Cool. Comfortable. I'm sure you're making the notes simultaneously, which will be your best reference every time when you attend the lecture. Before that, you need to see and go through all that and for all the revision purposes. Come on. Okay. Perpendicular lines. Perpendicular. The word is very easy. Lines which intersect at 90 degree, they are called as perpendicular lines. And by the way, there is one more word for perpendicular which you should be aware about. Yes, orthogonal. Correct? Cool. Parallel lines, the lines which never intersect. In short, you can say that the distance between them remains same throughout. Yeah, the distance between them remains same throughout. Correct. Now, if few more points, friends. Number of lines passing through a given point. From one point, how many lines can pass? Visualize. Correct. Infinite. A number of lines passing through two different points. Only one, right? One and only one. And if two lines are perpendicular to the same line, what about those two lines then? Yes, they'll be parallel. Correct. So this is a line. If two lines are perpendicular to the same line, means they both are parallel. Correct. Now, if you happen to see three parallel lines being intersected by two transversals, the intersecting lines are called as transversals. Then there's something like intercepts. So ratio of the intercepts made by these two lines are equal. Which intercepts? AB and BC, they are the intercepts. XY and YZ. So ratio of AB and BC will be same as ratio of XY and YZ. Okay, remember this. All right, let's go ahead, friends. Now all about angle. You know, lines part is done, basics. Now angle. Angle is actually derived from a Greek word angulus, and angulus means corner. So wherever you see a corner, don't you feel there's an angle? That is how it started. And based on its measure, we have these 6 names. Yeah. So if, and how do we define it, by the way? Two rays originating from the same point. Then this is the angle. This is called as vertex of the angle, the originating point. Yeah. A, B, C. So how do we name it? Angle ABC, angle CB, or just angle B. In short, vertex is in the middle. Okay. All right. Acute angle. If the measure of the angle is less than 90, it's acute angle. Equal to 90, yes, right angle. More than 90 but less than 180, obtuse. Equal to 180, straight angle. And if you go beyond 180 but just before 360, less than 360, it is reflex. And if you take one complete round, yes, it is complete angle. Okay, so you should be aware about these 6 terminologies with respect to individual angles. All right, friends, noted? Yeah, cool. Now let's talk about pair of angles. Supplementary angles. Yes, you will hear about them a lot of times. Yes, the two angles which add up to 180 degree, they are supplementary angles. Similarly, we have complementary angles, and here we have E. I nahi hai, E. The angles which add up to 90 degree, they are complementary. Okay, got it? Cool. Next part, adjacent angles. When I say adjacent angles, what do I mean? Adjacent. So you might feel angles having common ray. Are these two adjacent angles? Even though they have a common ray? No, right? Yeah. Then what about the next point? Next thought, common vertex. Yeah, you might feel the angle should have common vertex. Check this out. E is the common vertex, but still these two angles are not adjacent. Then we might feel let's combine both common ray and common vertex. Still one more point should be there. See, these two angles are sharing some part. This is like common between both the angles. This should not happen. So finally, we come to this conclusion, disjoint interiors. So the two angles having these 3 features, common ray, common vertex, and disjoint interiors are adjacent angles. So here angle ADB and angle BDC are adjacent angles. Okay. All right. Now, if we see angles in a linear pair, so the two angles that are adjacent and supplementary, that is one ray is common and the other branch is in the straight line, they are forming a straight line. Then they are angles in a linear pair, their value, their addition will always be 180 degree. Okay. Now, on a straight line, you can create many such angles. Addition of all of them will be 180 degrees. All right, simple, cool, easy, great. Now, as we discussed earlier, two lines, if they're in a plane, they can either be parallel or intersecting. Okay. Suppose here these two green lines are parallel and they are being intersected by a third red line that is transversal. Then we have some terminologies, some more special type of angles. First is corresponding angles. Just check this. So basically, if you like overlap these two green lines, which all angles will coincide? A will coincide with W, isn't it? So A will coincide with W, yes. C will coincide with Y, B with X, and D with Z. Okay, so these are called as corresponding angles. In similarity and all these things will be very, very useful. So understand this properly. Next is alternate angles, friends. Remember in childhood we used to Z banta hai. Yeah, Z. Yes, these are alternate angles. So you can see here C and X, similarly D and W. All right. Then interior angles. The name itself is clear. Interior, अंदर होगा. So C and W. Yeah. Similarly D and X. And finally, you have vertically opposite angles. So basically, whenever two lines intersect, you'll have two pairs of vertically opposite angles. Just see AD, BC, yeah, WZ, XY, like that. Okay. All right. Now, corresponding angles are always equal. Alternate angles are also equal. Vertically upward angles are equal and interior angles need not be equal, but their sum will always be 180 degrees. So they are supplementary. Correct. Got it till here? Yes, friends. All right. So this is a summary. So apart from those 6 words with respect to individual angles, then we move to pair of angles. It's complementary, supplementary, linear pair, adjacent angles, and finally these 4 more. So this is like the entire part, entire syllabus of angles. Okay, cool. Now you might hear this term bisector of an angle many times. So basically it's a line that divides an angle into 2 equal parts. So this angle ACD was bisected by ray BC. Yeah, so ACB is equal to BCD. Now one more special thing about this bisector is that any point on this bisector will be equidistant from both the arms. Now in the way we have studied in coordinate geometry already, distance of a point from a line will always be measured along this perpendicular line. This will be the shortest unique distance. Okay, so these two distances are equal. So any point on the bisector is equidistant from both the arms of the angles. All right, cool. Okay, now finally lines and angles done. Now what begins is triangle. Basic warm up is done. Triangle, how do we define it? Yes, three-sided closed figure. All right, the closed word is very important. To have a closed figure logically, friend, do you understand? You need minimum 3 sides. So if I generalize this, it's like n-sided closed figure is called as polygon, where n should be minimum 3. So we are learning 3-sided polygon, that is called as triangle. Okay, now let's understand the family members of the triangle. There are 6 members. Let's understand now. But how do we classify them? Yes, on 2 parameters, on the basis of 2 parameters, based on the sides and based on the angles. Now, based on the sides means the length of the sides. First possibility, if all 3 sides are equal, equilateral triangle. If any 2 sides are equal, correct, isosceles spelling. And third possibility is what, friends? Nothing is equal. Then it is scalene triangle. Okay, these 3 names are on the basis of the lengths, the relation between the lengths of the 3 sides. Now we have similarly based on the angles. So if one angle is 90 degree, it is right angle triangle, isn't it? And if one angle is more than 90, it is obtuse angle triangle. And if all angles are less than 90, it is acute angle triangle. Okay, 3 more names. So remember these 6 terminologies with respect to the family members of triangles. Okay, all right, comfortable till here? Let's go ahead. Now the properties, very, very important. The very first property, which is very famous, is about angles. All the 3 angles will always add up to, correct, 180 degree. That you know very well. But do you know why is that possible? Why is that it should be adding up to 180? Can we prove it? Yes, we can. See the very simple logical proof. I have just drawn a line parallel to one of the sides of the triangle. Then I can relate B and C with the other angles besides A. Can you see alternate angles getting formed? Z1 right now. This equal to this and this equal to this. Okay, friends. Now all A, B, and C are on the same straight line, so their addition will be 180 degree. One of the simplest proof for sum of all the three angles of a triangle is 180 degrees. Correct. Cool. Next. Now, very important, very crucial, very important for solving tricky questions. I'll name this property as triangle inequality. Triangle inequality. You know, if I just give you three lengths, it's not that you take any three lengths and you can form a triangle. See this logically first. First visualize. So this is A. I just opened it and make it flat. So A plus B is a total horizontal line. Now, let's see if this C is equal to A plus B. Yeah, as of now you saw na A plus B is more than C. So triangle was there, which we dismantled. Yeah. Now what if A plus B is less than or equal to C? Just check. This is equal to or more. That C is crossing A plus B. In that case, what will happen? Just check. Triangle was not possible only, friends. Just check. We couldn't form only. Means under this condition, triangle will not exist. Means for the triangle to exist, sum of two sides should be more than the third side. That becomes one of the very important properties regarding forming a triangle. Similarly, difference of two sides will always be less than the third side. Okay, so if I connect both of them, so any side, suppose ABC, I take C as one of the sides, it should be more than difference of other two. I don't know which one is bigger, so I'm putting the mod, and it should be less than the sum of the other two. So this we call it as triangle inequality. Remember this. This will help us to understand how many such triangles will exist. Sometimes they will give you two sides and third side they will ask how many possibilities are there. Something like that. So triangle inequality. Cool. Comfortable? Yeah, let's go ahead. Now, after understanding that how many triangles will exist, let's understand once the triangle exists, which kind of triangle is it? If before that, one more small relation, side opposite the largest angle is going to be the longest side. And similarly, the side opposite the shortest angle is going to be the shortest. Yeah, simple logic. जितना एंगल बढ़ेगा उसके सामने वाली साइड उतनी बढ़ेगी बराबर सिंपल बिल्डिंग दूर से दिखती है तो कितना छोटी लगती है एंगल इज सो स्मॉल एज वी गो नियर एंड नियर the angle increases so when we see oh wow there's a huge building the angle increased so side increased cool now what is perimeter boundary one of the simplest alternate word for perimeter is boundary total boundary matlab sum of all the sides okay so what will be semi perimeter the prefix semi wherever you see it means half yes so half the perimeter perimeter semi perimeter clear right okay now identifying which type of triangle is it so pick up the largest side square it suppose C was the largest side square it if it is less than the sum of the squares of the other two then it is a acute angle triangle if it is equal can you see it's a right angle triangle and if C square happens to be more than the A square plus B square it will be obtuse angled triangle this is how we identify the type of triangle based on the length given to us identifying isosceles, scalene, or equilateral is going to be very easy. You can manually, with the naked eyes, you can check the values of the sides and you can come up with that relation. But identifying a right angle, acute angle, obtuse angle, this is the thought. So you need to figure out the square of the largest side and accordingly relate it with the sum of the squares of the other two sides. And there are these three possibilities only, right, friends? It will be less, equal, or more accordingly acute angle right angle or obtuse angle okay Cool, comfortable? All right. Now about exterior angle. So you can just extend the sides of the triangle and you'll keep watching the development of new angle that is outside the triangle. That angle is getting formed outside, so it is exterior angle. Let's try and derive some relation for it so that we can use in the question quickly. See, even if you don't know this, you can still solve it, but it will take slightly more time. See, one relation we know about ABC, their sum is 180. Also, did you see A and Z are on the same straight line? So linear pair. So that addition is 180 degrees. So if you compare both of them, did you see Z is nothing but B plus C? And this is how we say exterior angle is equal to sum of its remote interior angles. This is the theorem, friends. Apply this for every exterior angle and you'll get these three relations. All right. Now, if I add all the three, x plus y plus z, can you see A will be getting added two times, same with B and same with C. So two common, A plus B plus C. Now, A plus B plus C is 180. So 2 times 180, friends. So sum of all the exterior angles of the triangle is 360 degree. And it is true for all the polygons. Sum of all the exterior angles will ultimately be 360 degree, friends. Okay. All right. Cool. Now, there are four special points of a triangle. How are they getting formed? Let's understand the background behind it first. The four more terminologies now. Median. What is median? Yes, it's a line joining the vertex to midpoint of opposite side. The main thing is it should join the midpoint of opposite side. Next is altitude. What is altitude? From vertex, you just draw a perpendicular on the opposite side. It is called as altitude. Cool. Next is angle bisector. It's a line which bisects the angle into two equal parts. Bisects two equal parts. And finally, perpendicular bisector. Yeah, it's a perpendicular drawn from midpoint of any side. Got it? Okay. I think वो corner में था तो दिखेगा नहीं. So just check. I'm drawing again. So if you take the midpoint of this side and draw a perpendicular from there. So this is your perpendicular bisector. This was angle bisector. This is altitude. This is median. This is how I will denote them. All right. Let's understand the first point in detail. Centroid. How is the centroid getting formed? Point of intersection of all the medians. Okay. If you draw all the medians, the beauty is they will all meet at one unique point. That one unique common point is called a centroid. The very first property. This median divides the triangle into two triangles of equal areas. Secondly, centroid divides the triangle into three triangles of equal area. Dekha? Okay. Now next is very important property. Centroid divides the median in the ratio of 2:1, 2 towards vertex and 1 towards base. This way, this way, this way. Okay. And we have one more relation. 3 times the sum of the squares of the sides is equal to 4 times the sum of the squares of the medians. So when sides ka length is given, medians ka length is given, one of the medians is not given, or all medians are given, 2 sides are given, third side is not given, something like that. This is how you should think. Yeah. This is like inspired by a theorem called as Apollonius theorem. Let's see that. I hope you're comfortable till here. Keep making your notes. Yeah. Apollonius theorem. Check this. So basically, suppose I'm applying on the vertex A. From vertex A, you write down the two sides of the triangle. So and square them and add them. AB square plus AC square. Okay. Now from same vertex A, there is also one more median originating, right? Which is AD square. So AB square plus AC square plus is equal to twice AD square plus twice DB square. Either you write DB or you write DC. Both are one in the same. Equal length, right? This is your Apollonius theorem. So accordingly, you can apply this on every vertex. AB square plus AC square is twice AD square plus twice DC square. Okay. Simple. This will help us to find the length of the median. Median का length के लिए ये सबसे best choice. And this was derived using Pythagoras only, friends. Cool. Orthocenter. So if you draw the altitudes, they will meet at one common point, and that common point is called as orthocenter. Okay, that's the beauty. You can denote it by O or H. Centroid, you can denote it as C or G. First point which you should know is angle at the orthocenter is supplementary with the corresponding vertex angle. That is COB plus CAB is 180. You'll understand this reason very well in circles chapter. Okay. All right. Now next property is, yeah, next property is this one. And how we got this in circles, or you can also derive this here only using Pythagoras and all. Okay. And using the angle property, mix and match करके end में derive हो जाता है. So don't worry about derivation so much, but please remember these relations, these shortcuts. Second point, you don't have to by heart at all. Just apply Pythagoras theorem in ACD triangle and triangle ABD. And AD square दोनों में common होगा, right? So you can equate using that. You can connect both the thoughts using AD square. So really don't need to by heart this. Ultimate background is Pythagoras theorem. So right angle है तो length की बात चल रही है तो Pythagoras click होना चाहिए. Okay, all right, cool. Let's go ahead, friends. Yes, champions, comfortable? All right. So next is in center, point of intersection of angle bisectors. All the angle bisectors meet at one common point. That one common point is called as angle bisector. Yes. First property about angle at in center, CIB, is 90 degree plus half the corresponding vertical angle. So 90 plus half of CAB. This can also be derived, but deriving will take some time. So please remember this. Okay. Second point, angle bisector theorem. See how I remember this. Dash equal to dash. Okay. अब मैं ये property vertex A पे apply कर रहा हूँ. So angle A is getting bisected, right? So starting with A, write on the two sides of the triangle in any order. So AB, AC. Okay. Then retain B and C. Replace A with the other end of that bisector, which is D. If you remember this way, you will never forget. Okay. Similarly, if I apply this for exterior angle triangle, so this is the exterior angle which is getting bisected by this ray. Then we extend this side of the triangle. So, but this is A, B, C, D. So, dash equal to dash, same funda. Vertex A, angle A was getting bisected, right? So AB upon AC, same thought, retain B and C, replace A with D. Perfect. Cool. Got it? This was exterior angle bisector theorem. And this is your interior angle bisector theorem. All right. Comfortable? Okay. Now, you know the beauty of this point I, why do we call it as in center? The main feature is this in center is equidistant from all three sides. If you take that I as center and that distance as radius, you can draw a circle which will touch all the three sides from inside. So that is why we add the prefix in. So in circle, in radius, in center. Clear? Yeah. And ultimately one more point, area. Area of the triangle is in radius into semi-perimeter. So there also this in radius is connected, friends, in area also. Got it? Comfortable? All right. Finally, the last one, circumcenter. Yes. Point of intersection of all the perpendicular bisectors. This is the first one, second one. So they met at that point. That is nothing but the circumcenter. Okay, first point, angle at circumcenter is twice the corresponding vertical angle. This you will understand clearly in circle. There is something called as inscribed angle theorem. उससे आता है ये. So RCQ is double of RPQ. Cool. Now this circumcenter, the location of this circumcenter is such that it is equidistant from all the three vertices, all the three endpoints, all the three vertices, friends. And that is circumradius. So you can take that point as circumcenter, that is center only, take that fixed distance as radius, and you can easily draw a circle which will touch all the 3 points from outside. So it will circumscribe the triangle, isn't it? Okay, that is why the prefix circum. So circum, circle, circum radius, circum center. Finally, area of the triangle in terms of circum radius is this product of all the three sides A, B, C divided by 4 times circum radius. All right. Cool. Now, in case of isosceles triangle, all the 4 lines are the same line for the vertex enclosing the equal sides. Check this. If I draw this median, it is altitude, angle bisector, perpendicular bisector, everything. So if I draw other median, so that will be centroid, the meeting point of the medians. Yeah, एक और बार revision हो रहा है. If I draw altitude, meeting point of altitudes, orthocenter. If I draw one more angle bisector, yes, meeting point of angle bisector is in center. If I draw one more perpendicular bisector, meeting point of the perpendicular bisector is circumcenter. So you can see all these 4 points are collinear in isosceles triangle. Okay. Similarly, in case of an equilateral triangle, all the 4 lines are everything. All the 4 lines, that is median, altitude, angle bisector, and perpendicular bisector sides, are the same line for all 3 vertices. So this AD is everything. AD is all 4, BF is all 4, CE is all 4. Okay, it means all the 4 points will be one and the same. They all will coincide. All right, champions, comfortable till here? Please keep revising again and again. Very important. Now, friends, after learning and understanding about these 4 points, let's visualize their positions, their locations in all the 3 types of triangles. So in acute angle triangle, yes, what is this? Orthocenter. Altitudes का meeting point. What is this? Medians का meeting point. Centroid. By heart हो जाना चाहिए. ये क्या है? Perpendicular bisectors का meeting point. Circumcenter. And finally, angle bisectors का meeting point. In center. So all the 4 points lie within the triangle. Okay, simple. Let's see in case of a right angle triangle. Do you understand? The 2 sides, the 2 perpendicular sides themselves are altitudes. So they are meeting at the point containing the right angle. So वही होगा orthocenter. Orthocenter is on the perimeter now, on the boundary. Centroid तो अभी भी अंदर है. Perpendicular bisector is at the midpoint of the hypotenuse. Because this point has to be equidistant from all the 3 vertices, right? So circumcenter is again moved on the boundary, especially midpoint of the hypotenuse. So circumradius will be half of the hypotenuse. बराबर है? Okay. And in center is inside. So orthocenter and circumcenter are on the perimeter. In case of a right angle triangle, get this clarity. And finally, in case of obtuse angle triangle, सबसे पहले altitudes बनाएंगे तो बाहर मिलेंगे वो लोग. So orthocenter will lie outside. Centroid अंदर है. Circumcenter will also lie outside now because perpendicular bisectors will meet outside, and in center is inside only. So finally, orthocenter and circumcenter go outside. So you should be clear with this much, especially about right angle triangle. Okay. Now next is advanced properties of a right angle triangle, especially about right angle triangle. So orthocenter of a right angle triangle is the vertex where the 2 perpendicular sides of the triangles meet, right? Circumradius of what was what for right angle triangle just now we saw? It is half the length of the hypotenuse, and circumcenter is the midpoint of the hypotenuse. Okay. Now I have drawn one more altitude BD. Can you see three triangles getting formed here? Three right angle triangles. Yes. And by the way, all three of them will be similar. The similarity I will be discussing very soon. All three of them will be similar, and based on that, we can derive these relations. सबसे ज़्यादा frequently used ये वाला होगा BD square is AD into DC. Now, one more beautiful relation is there which you should know. AB into BC is same as AC into BD. Why so? Simple logic, area. So half into AB into BC, area. If you visualize this area in terms of AC being the base and BD is the height. AC is the base and BD is the height. All right, friends. Same area, na? Same triangle. So half half cancel. So ultimately AB into BC is AC into BD. Understood? Remember this. Okay. Now finally coming to area of the triangle, the first formula. When all the three sides of a triangle are given to us, friends, what will you do? Logically, first try and check, is it a right angle triangle or not? कैसे check करोगे? Largest side का square करने का and square and add other two sides. Remember that what we had done for types of triangle में? C square is equal to A square plus B square आया, तो it has to be a right angle triangle. तब तो area बहुत easy हो जाएगा ना, half into base into height. If not, then you can go for this Heron's formula, where S is semi-perimeter. So inside the root, you have four terms: S, S minus A, S minus B, S minus C. Yes. Second one is your favorite, half into base into height. Yeah. Third one, if you know the angle between the two sides, so half into product of those two sides into sine of angle between them. So half AB sine theta. Okay. Fourth one we have seen already in terms of in radius. So area is in radius into semi-perimeter. Fifth one, product of all three sides divided by 4 times circumradius. We just saw this sometime back. Sixth one is that shoelace method wala formula when all the three vertices are known. Half into mod of, remember, first vertex, second vertex, third vertex, first vertex again. So this into this minus this into this. Shoelace banega plus this into this minus this into this plus this minus this. Overall, these 6 thoughts should be with you whenever you deal with area of the triangle in the entire syllabus. Okay, all right, champions. Cool. Now something about equilateral triangle. You know very well all three sides are equal, so all angles are also equal. So each angle is 60 degree, right? Yeah. Now this is exactly bisecting the triangle. And you know, this is all 4 lines. This is median, altitude, angle bisector, perpendicular bisector, everything. So how do I find the length of this hypotenuse? So this will be like x by 2. You can apply Pythagoras. This square is equal to this square plus this square. Keep simplifying. At the end, you'll get height of the equilateral triangle as root 3 by 2 into side. Now, one more interesting thing. If I see median will be, centroid will be nothing but somewhere on that median only in the ratio of 2:1. Yeah. Also, you know, in case of equilateral triangle, all 4 points are one and the same. Remember, so this is also in center. That one jo hai na, one chota wala, that will become in radius, isn't it? Distance of that in center from sides, all sides equal होता है ना, उसी को बोलते हैं in radius. And if I see that it's circumcenter, then that lamba wala 2 part will become circumradius. So in short, circumradius to in radius will be 2:1. So in radius will be 1/3 of the entire median or entire height. So 1/3 of h, so 1/3 of root 3 by 2 into x, and circumradius will be 2/3. 2/3 of root 3 by 2 into x. So h का value substitute करके solve करोगे, x by 2 root 3, and this will be x by root 3. All right. I hope you got it. Cool. Okay. All right. Now area, half into base into height. Height just now we derived, and base was x. So half into x into root 3 by 2 into x. So ultimately root 3 by 4 into side square. Okay, got it? Super. Now, if I give you a fixed perimeter and using that perimeter, if you draw all the three types of triangles, we make all the three types of the triangles, that is equilateral, isosceles, and scalene. Equilateral will have highest area, followed by isosceles and then scalene. In algebra, we have done it. Product is maximum when all the values are equal. Isn't it AMGM inequality? Correct, champion. Superb. Now, something about a right angle triangle. Advanced properties we have already seen, but Pythagoras was pending. So what is Pythagoras theorem? Hypotenuse square is equal to sum of the squares of the perpendicular sides, right? Now, what are Pythagorean triplets? Yeah, some of set of three numbers that satisfy this Pythagoras theorem, or they form the sides of a right angle triangle. For example, 3, 4, 5, 5, 12, 13, 8, 15, 17. These are the triplets, right? Now, how do we derive a triplet? Very important. If you want to save your time, I'll show you in the questions how we smartly use Pythagoras triplets and avoid that squaring, square rooting, all those things. So let's first understand this in two categories. First, beginning with odd numbers. Whatever number you're beginning with, that is going to be the smallest. So square that smallest number. So 3 square 9. Then split that 9 into two consecutive numbers. Means you have to find two consecutive numbers, consecutive, whose sum is 9. So 4 and 5. This is the triplet. 3, 4, and 5. All right. Great. One more, 5. The first step, 5 square 25. Split 25 into two consecutive numbers, 12 and 13. So 5, 12, and 13. Got it? All right. Now let's understand how do we make the triplet starting with an even number. Square the smallest, divide by 4, then take the previous and the next integers. Let's see. 6. So 6 is going to be the smallest, right? 6 square 36. Divide by 4. So it is 9. 1 less and 1 more. So 8 and 10. So 6, 8, and 10 becomes a triplet. Okay. 8. 8 square 64. Divide by 4, 16. Minus 1 plus 1. So 8, 15, 17 becomes a triplet. All right. One more interesting fact which you should know, that if you take a triplet and multiply that triplet with the same number, that is common multiple of any triplet will also be a triplet. So just check. 3, 4, 5 था, 6, 8, 10 भी होगा. 5, 12, 13 into 3 triplet, and so on. Okay, got it? All right, friends. The next thought is again very important, very widely used, बहुत important. Similarity and congruence. In this, especially similarity. Yeah. So let's first understand this concept. This is a triangle. इसी की तरह एक डिक्टो और एक ट्रायंगल उठाया मैंने. What can we call them? Yes, congruent triangles. Exactly same, ditto. So same shape and same size. ये ABC length है तो इधर भी ABC होगा. If all the angles here are X, Y, and Z, so there also it will be X, Y, and Z. So all sides are equal and all angles are equal. So in general, how do we test it? Yes, the famous tests are triple S, SAS, ASA, and RHS. RHS is nothing but right angle hypotenuse side. So basically, it's about connecting two right angle triangles. Yeah, angle side angle. So two angles should be equal, and the side included between them should be equal. That way, two sides and angle between them is SAS. Okay, we'll see this all application in the questions when we solve the questions. Okay, friends, just remember this. Now, this triangle, check. Congruent, isn't it? Oh, not congruent, but I can definitely say similar because shape change नहीं हुआ, खाली size change हो रहा है. Oh, bigger, very small. क्या है ये? Similar triangles. This is similarity, friend. Something like your magnifying glass wala funda. Same shape, but size may or may not be the same, right? So, if you understand who is responsible for maintaining the shape, angles, correct? Angles. So, all angles are equal. That's the main feature, friends. इसी के दम पे टेस्ट बनेगा डबल ए टेस्ट. So if two angles are equal, by default third angle भी equal ही होगा. So all three will become equal. So सबसे famous test for similarity will be AA test. Now see the sides का relation. ABC the original one, and the other, if one is doubled, all others will also be doubled. Okay. If one is halved, all others will also be halved. And if one is 1/10, sub 1/10 होगा. So corresponding sides are proportionate. Okay, proportionate. Great. The tests are AA, SAS, SSS. Just note one thing here, sides need not be equal, but their ratios should be equal. देख रहे हो ना, A/2 is 1/2, तो सब जगह 1/2 का ratio maintain हो रहा है ना. When ratios are equal, similar triangle. When values themselves are equal, which you can also say as ratio is 1:1, then they are congruent. So like congruent is a special case of similarity. So all congruent triangles are similar, of course, but reverse is not true. Huh? I hope you got it. Okay. If two triangles are similar, friends, then ratio of all the linear dimensions, whatever you can think of, sides, the ratio same hoga, equal to medians. It will be same as the ratio of the altitudes. It will be same as the ratio of angle bisectors. It will be same as the ratio of their in radii. Yeah, it will be same as the ratio of their circumradii. Okay. All the linear things will have same ratio. Okay. If two triangles are similar, then also you should know that area, ratio of their areas will be nothing but square of the ratio of the sides. This thought. For example, if the ratio of the sides of the two triangles which are similar is 2:5, then ratio of their areas will be 2 square is to 5 square. So 4 is to 25. If two triangles have the same base, yes, ratio of their areas will be same as ratio of their heights. Okay. Check. So half B1 H1 equal to half B2 H2, but bases are equal, तो उस हिसाब से ऐसा हो जाएगा बराबर. Only H1 upon H2 will remain. But bases are equal, they cancel like that. And if they have same height, the ratio of bases. See these two triangles. Okay, easy. Okay. If two triangles have same area, A1 equal to A2, so half B1 H1 equal to half B2 H2, so B1 H1 equal to B2 H2, so ultimately B1 upon B2 is equal to H2 upon H1. Okay, the bases will be inversely proportional to their heights. All right. Now, special cases of similarity. See this situation. Can you see if DE is parallel to BC? These two angles are equal corresponding. Similarly, these two are equal corresponding. This is enough to prove those two triangles similar. Third angle to by default equally over. So you can say ABC will be similar to ADE. Naming is very important. Naming of the triangles is very important. You have to match with angle to angle. Okay. Okay. So then you can write corresponding sides. They all will be in the same ratio. All right. One more situation, something like this. Alternate, vertically opposite. So they are also similar. But just say the naming A, B, E, A equal to C ना, तो A के जगह पे C आएगा, and B is equal to D, तो B के जगह पे D आएगा. So A, B, E is equal to C, D, E. Yes. And accordingly, you can write the corresponding sides. They will be in the same ratio. Cool. This one we have already discussed. Just the thought, right? All the three right angles will be similar. Q, just check X and O. X plus O is like 90 degree. They are complementary friends because one angle is already 90. सबको मैं दोनों triangle को बाहर निकाला. So X plus O is 90. So in this triangle, this will be O, and in the other triangle, this will be X. So you can see all these three triangles have all three angles equal. So definitely they are similar, right? Just check the naming. ABC similar to ADB, similar to BDC. Angle to angle match करने का. So ratio of the corresponding sides. Yes. From here only we prove BD square is equal to AD into DC. Okay. Great. Now finally, basic proportionality theorem. Just an extension of similarity further. Yeah. So if a line is parallel to any side of the triangle, it divides the other two sides proportionately, means in the same ratio. If D is parallel to BC, AD over DB will be same as AE over EC. And the reverse is also true. If these two ratios are equal, then DE has to be parallel to BC. Correct. Further extension of that midpoint theorem means now D and E are not any points on those two sides. There will be nothing but midpoints. So a line joining midpoints of the any two sides of a triangle is parallel to its third side, and the length is half of that. So if D and E are midpoints of AB and AC respectively, then we have two things. DE will be parallel to BC and DE will be half of BC, right? Because ADE and ABC will be similar triangles. AD upon AB will be half because these midpoints. So same ratio will be maintained throughout. That is why this one. Okay. All right. Now one more special case which you should remember is this. So here X, Y, and Z are all parallel. So let's define these two lines as A and B. So in this, friends, both the triangles are similar, right? Just now you saw the application part. Yeah. So A upon A plus B will be same as X upon Y. Similarly, in this triangle, B upon A plus B will be same as X upon Z. Add them. So what did you get? Yes. This becomes 1, right? A plus B upon A plus B. Divide by X. This is a beautiful relation. The reciprocal of the middle one is equal to sum of the reciprocals of the extreme ones. All right. Okay. Cool. Great. Angle bisector we have already seen. Dash equal to dash. Yes, friends. This was interior. Similarly, exterior. Same funda. Dash equal to dash. All right. Cool. Now, especially in trigonometry, I'm just telling you a very small part. The detailed part, I'll be making a new video, a separate video in which we'll be explaining all the basics of trigonometry, which is like in basic importance with respect to cat and all. Very minute things, don't worry, okay? Now, here, two very simple things, angle of elevation and depression. What are they? How to relate them? So see, this is our normal, yeah, normal line of vision, which is like nothing but parallel to the ground. So whenever you see something, you always see parallel to the ground, right? Your line of vision will always be parallel to the ground. Okay. Now, if an object is at a higher distance, at a higher level, so you'll have to raise your eyes at that level, right? So whatever angle you have to raise it by, that angle is called as angle of elevation. And when you see something down, नीचे से कुछ आ रहा है. Yes, देखो आया. So you have to raise your eyes down. नीचे देखना पड़ेगा. So whatever angle you had to move it down by, that is called as angle of depression. They all will be with reference to this normal line of vision. Okay, let's apply this in this thought. So whenever we have two different heights, people are at two different heights. If they want to see each other, first of all, this is the normal line of vision. Both are parallel because both are parallel to the ground, right? So they see, when both of them see each other, for the higher person, higher heighted person, angle of depression, for lower heighted person, angle of elevation, and both these will be what, they are forming a Z now, alternate angles, so they both will be equal. So if two people are watching each other, angle of elevation of one will be same as angle of depression of the other. All right, simple funda. Okay, great. Now special right angle triangles, remember, very very useful. First one is 30 60 90 triangles. Yeah, ratio of the sides to be maintained is this: side opposite 30, if you take it as 1, so side opposite 60 will be root 3. So according to Pythagoras, side opposite 90 will be 2. So x, 2x, 3x, 30 60 90, so 1 root 3 and 2. This will be the ratio maintained always in a 30 60 90 triangle. 30 60 90, 1 root 3 and 2, this one. Okay, similarly we have one more, 45 45 90 triangle. What can we call it as? Isosceles right angled triangle. Correct. So both these sides are equal, let it be 1. So according to Pythagoras, the hypotenuse will be root 2. So the ratio to be maintained will always be 1:1 is to root 2. Okay friends, x 2x, root 2 into x, sorry. Based on this, I can also derive one more, 30 30 120. You can derive at any point of time, but if you remember, it will be better. So 30 30 120 triangle, friends. 30 30 120. So this is isosceles. Two angles are equal. So sides opposite them will also be equal, and vice versa. And one angle is 120, more than 90. So obtuse angle. Clear है? Visualize कर लिया. So 120 को we can bisect, no? And you'll get two triangles of 30 60 and 90. Yeah. So this will be like root 3 by 2 into side, because this will be 60, this will be 60. So root 3 by 2 into x, root 3 by 2 into x, overall double of root 3 by 2 into x, so x root 3. So here the ratio to be maintained is 1 is to 1 is to root 3. If you remember better, all right, I'm going to derive every time. Okay, champions? Cool. I hope you have noted down everything, and with good enough revision, you'll be able to retain so much. Yes. Nothing new. You have already done this in school. Yes. So friends, don't get scared with this derivation. It is very important, very easy. After circles, you can again derive this. Okay. So mainly for a right angle triangle, three more things which you should know. If uh, if the perpendicular sides are A and B and the hypotenuse is C, which you can see here. So how to find in radius? This is the way you find in radius. Small r means in radius. A plus B minus C divided by 2. So sum of the perpendicular sides minus the hypo divide by 2. And circumradius, so you know very well, it is half of the hypotenuse length, correct? Also, one more relation which you remember is altitude to hypo. So if you draw a perpendicular to the hypo, it will be less than or equal to half of the hypotenuse. It will never be more than that. Okay. All right. Please note it down also. Note this also. One more last thing, friends. Suppose if ABC are the sides of a triangle, you remember? Yes, that property, sum of the two sides should always be more than the third side. Yeah. Also, what is perimeter? Yes, sum of all the three sides. From this, I can derive something for A plus B. Yeah. We can conclude that P minus C will be same as A plus B. And what is semi-perimeter? Perimeter divided by 2. So A plus B, instead of A plus B, can I now write P minus C? From that relation, yellow one. Okay, so P minus C is more than C. Add C. So P is more than 2C. So perimeter divided by 2 is more than C. And perimeter divided by 2 means half of perimeter, means Semi-perimeter. So, and suppose C was the largest side. So, what is the conclusion? Largest side of any triangle will always be less than the semi-perimeter. This can be a good start in some tricky questions wherein you are exploring how many such possibilities of triangles will exist. All right, champions. Okay. Great. Thank you. So this was all about lines, angles, and triangles. This is the bare minimum content which you should know properly before going ahead, before solving any sum. I know you might feel whatever you're feeling. I know I can understand. Keep repeating, keep revising. It will be absolutely normal after some good enough number of revisions. When I could do it, you can definitely do it. All the best. See you in class with more and more sums. Take care. Thank you. Thank you for devoting so much of precious time of yours. Thank you so much. Take care. Bye bye. Stay safe.